So then the Organic 2 syllabus, this is the class that I'm teaching right now in lecture. And I wanted to set this up so everything would be parallel. So in the first week, we did reduction of carbonyls in lecture. Now they're doing a reduction of carbonyls in lab. And we set this up. The way I've got it set up here is a couple of weeks of synthesis. And then in the textbook, we go into spectroscopy and spectrometry. Of course, Beyond Labs is going to be useful for that. And then we finished up with a whole bunch of reactions that are classic at the end, doing synthesis. But the goal here was to get people thinking on their own. So towards the end of this, when I show you some examples, the students have to design the experiment. I've never been able to do that at the sophomore level. The students now have to put together, they have to do retrosynthesis, they have to think about what they're going to do on the day, and they have to do it, which is really powerful. So let's talk about an example here. This is the IRMS type material that we did with the qualitative analysis part of Beyond Labs, where we're looking at functional groups. And I'm going to date myself here, but we're spoiled these days by instrumentation, and students don't appreciate wet chemistry from the past, right? And in many places, we don't do those test tube experiments anymore, which we did when I was a kid. But this was the chance to do both of them. So the first part of this was IRMS and qualitative analysis. We gave them a bunch of different compounds to work with from the chalkboard and a bunch of different tests to do. Some are negative, some are positive, and they would write their observations down. And then just an example here, this is methyl cyclohexene. We're going to do a fairly simple bromination test. Obviously, that's a test for the presence of an alkene. And the actual visualization of this was brilliant. The fact that it disappears, the fact that the color dissipates over a few minutes here is brilliant, because then they can see it happen. Instead of just being told it's happening or reading about it, they see it happen. And that was great, because now all of a sudden they have a positive test for an alkene. And if they throw this together, maybe with it's the same alkene, maybe they put some HCl in, or they put some sodium hydroxide in, it doesn't mix because they're not compatible. They can see this, right? They have something to grab a hold of. So that was great, and they really started to enjoy that. And then we moved into doing the actual spectroscopy. Infrared spectra, I love the fact that the database is huge. I think there are 700 and some spectra in there. So one of the problems I've always got in organic chemistry at the sophomore level is getting eyes on spectra, is getting kids to have spectra in front of them to recognize they don't all jump around, signals don't move, this is reliable and this is predictable, and this really worked. So we got all this data back, and the students again are writing reports. There was a 2-part report on the day, and then a later submission for the rest of the grade. Here is the outcome. This is again a student's input, where we have all the positive tests or negative tests, and then we have on the right what happened, and then at the end of the report, why things happened. So it really worked for us. In terms of the spectroscopy part of it, we're interested in key signals for the most part at this level. So we're looking at IR spectra for functional groups, mass spectra, we're looking at the M+ and the base signal. So they were able to collect those pieces of information and then fill this in. So this was something they had to come up with. We led them to do tables, and they were able to put tables together quite nicely, where all of this now is looking at spectra. And we test them on that in the lecture part of the course. So this helps with that. NMR, again, we're spoiled. We have 2 400 megahertz NMR spectrometers at my fingertips at work, but we need to give the students historical perspective. And we chose a bunch of different samples to play with, and they did the functional group tests again, and then they went ahead and did the spectra. So this is just cinnamaldehyde. You know, it's full of wonderful signals, doublets and what have you. Using the NMR spectrometer in this situation with the qualitative analysis was great because it was simplified. They got used to looking at the spectra, and then we'd ask them to interpret the spectra for the report, and they could switch the nucleus very quickly, which I think is genius. You can see the signals, you can expand the spectra, and the students have to look at spectra and analyze them, which is really what we're trying to get done there at that part of the class. So that worked very well. And then they would report this type of data. And because we'd all mixed up the compounds, not everybody had the same data, so we sort of minimized the collaboration, and that was good. And again, the reports became very, very impressive. So at the end of this, my last example is the go do it yourself type of assignment, where we're giving them 3 different compounds. We were just done with the Claisen and the aldol reactions. So A is a Claisen condensation, B is a Carnarvon-Algol reaction, and D is a crossed aldol reaction. And the students weren't told how to do this. It says down at the bottom, the guidance was, you choose the solvents, you choose the starter materials, go do it. And they did. For the most part, they got it done, which was great. So then at the end of that, we can see now they have to choose from the different parts of the chalkboard. They're not guided where they need to go. They go find it themselves. They experiment. If it doesn't work, if you use LDA as the wrong base, it doesn't work. If you use the wrong solvent, it doesn't work. And it took a couple of hours for people to get this all to come together. But the feedback I got was great. People thought it was wonderful because they got to play around, they got to experiment with stuff. TLCs again showing the output, and at this stage now they know how to use Beyond Labs, and they're starting to think like chemists. They're starting to think that sometimes things go wrong, I can fix that, I can experiment, and I'm not just doing what we describe as cookbook chemistry. I'm thinking.